So if you recall from our last video, we had said that numbers 1, 3, 5, and 7 on this review sheet were exact solutions, right? They yielded exact solutions because they all dealt with trig wheel values, okay? So that means that the remainder, namely 2, 6, 4, and 8, are going to yield approximate solutions because these are not going to be trig wheel values, but these are going to be solutions that we're going to have to come up with by using inverse trig functions on the calculator. All right, so let's take a look. So we look at number 2 here and we say, all right, it says the sine of x equals square root of 3 over 4. Now the square root of 3 over 4 might look somewhat familiar, and you might say, this actually should be a trig wheel value, but it's not, right? Sine x equals the square root of 3 over 2 would be a trig wheel value. So this is not going to be a trig wheel value, so what we're going to have to do is we're going to have to realize, hey, well, I actually have on my calculator this nifty little inverse sine function, right? Above the sine button on the calculator, so I'm going to use the second function. So what you're really doing here is you're really saying, all right, well, on both sides, I can take the inverse sine, right, of both sides, and I would end up with x equals the inverse sine of the square root of 3 over 4. So what I'm going to do is I'm just going to punch this in my calculator. Just when you do these, just make sure you are in radian mode, because we will deal specifically with radian mode. So you want to make sure that when you do mode, it says radian, right? Enter. Good. So what I want to do is I want to do second sine, right, which is the inverse sine, and then I'll type in the square root of 3 over 4. So there's the square root of 3 divided by 4, and hit enter, and that gives me my angle, right? So my angle is, again, depends on how many decimal places they want. I'll say 3 in this case, so 0.448. So again, remember, this inverse sine function is either giving us a value in the first quadrant or the negative value in the fourth quadrant. So in this case, the 0.448 is going to be in the first quadrant, right? It's this. It's the value up here in the first quadrant. So remember from before, sine is also positive in the second quadrant, so we want the second quadrant angle that has a reference angle of 0.448. So if you remember this from the previous class, if you knew the reference angle, how would you get the corresponding angle in the second quadrant? You would do pi minus the reference angle, right? So the other solution that we want here is actually going to be pi minus 0.448, and that's going to be the angle in the second quadrant, right? That has the reference angle of 0.448. And then we just do what we did in the last problems where we realize, hey, these solutions are going to come around every 2 pi in that direction and every 2 pi in the other direction. So we're just going to add 2 pi times any integer, right? K is any integer. So there's our solution there. Right, so we use the inverse sine function on the calculator to get the first quadrant solution, and then we just realized that we needed to do pi minus that solution to get the solution in the second quadrant. All right, and then number 4 just deals with cosine. So with this one, we would have to divide by the square root of 3, so we ended up with the cosine of x equals negative 1 over the square root of 3. And again, this one, it could be tempting to think that this is another trig wheel value, because it actually is, but it's a value for the tangent, right? The tangent is 1 over the square root of 3 at pi over 6. But this is not the tangent, this is the cosine, so we're going to have to again use our calculator, right? So in this case, we do be doing inverse cosine on both sides. So we'd say x is the inverse cosine of negative 1 over the square root of 3. So we'll punch this in now. So we'll do second cosine, and we want negative 1 divided by the square root of 3. And this is going to give us 2.186. So we have 2.186 But just realize again now, this is cosine where it's negative. So this value that it gave us here, 2.186, since it's negative, it's giving us the second quadrant value. So we also need the third quadrant value, right? And this is where what I had mentioned before comes in handy. If you remember what we had said about cosine being an even function, if 2.186 is one of the solutions, since cosine is even, that means that negative 2.186 is going to be our other solution, which is a beautiful thing to keep in mind, right? So with cosine, if we have one solution, we just take the opposite of that, and that'll give us the other solution. So 2.186 and negative 2.186 are our two solutions. But again, just remembering this whole idea of the wraparound, right? You keep getting back to the same value as you wrap around the circle each time, either in the counterclockwise direction or the clockwise direction. So you add 2 pi k to both of these solutions, and we get our general solution there. Okay, so there's our solutions for number 4. And then with number 6, we have 2 tan x plus 5 equals 0. So we would solve this for tangent of x first, right? So we would subtract 5 and divide by 2. So we get tan x equals negative 5 over 2. But again, this is not a trig wheel angle. Therefore, we would need to do inverse tangent of negative 5 over 2. We punch this in our calculator. Negative 1.190. But again, remember what we had said previously about tangent. Tangent, once we have one value, we're really done because of the fact that this has a period of pi and not 2 pi. So negative 1.190 plus pi k is going to be our general solution. All right, so just remember with tangent, once you have one solution, you're really done. And you're just going to add pi k to that because of the fact that it has a period of pi and not 2 pi. So there's number 6. And then number 8 is the only one that's a little bit tricky maybe because of the fact that you're going to get a negative value for the sine. So here you would subtract 1 and divide by 6. So we would end up with sine x equals negative 1/6. So we're going to do what we've been doing, right? Solve this by taking the inverse sine of negative 1/6. And when we do that, inverse sine negative 1 over 6, it gives us a negative value. And that's the only thing that might be a little bit of an issue here. So it's negative 0.167 plus 2 pi k, right? Now that we've done enough of these, we realize, hey, we're just going to keep getting more solutions as we wrap around the circle. So that's one solution. But now here's the thing. This is where you got to think about where this solution came from. Negative 0.167. That looks better. It's a smaller negative sign now, right? Negative 0.167 is actually there, right? But if you think about that, all right, that's negative 0.167. So that really means that the reference angle for this is actually this, which is just the opposite, right? So the reference angle here is positive 0.167. So we already have the solution that's in the fourth quadrant. So where else was the sign negative? In the third quadrant. So we want the angle in the third quadrant whose reference angle is 0.167. So if you remember the rule, remember we had given you the rule for the second quadrant earlier that it was pi minus the reference angle. In the third quadrant, the rule was always pi plus the reference angle. So we want this third quadrant angle who has a reference angle of 0.167. So it's going to be pi plus 0.167. So that's the angle that we want in the third quadrant. And then again, wrap around. So we keep adding two pi k to it. So then your solutions are negative 0.167 plus 2 pi k, and then the other solution would be pi plus 0.167 plus 2 pi k. Okay, so the first solution was the fourth quadrant angle, and that second solution there was the third quadrant angle.